Scientists warn that the Titanoboa could theoretically return. This is not mere alarmism. Following the 2009 discovery of a 15-meter snake fossil, researchers uncovered a disturbing climatological link. The species went extinct due to a global temperature drop of 3 degrees, a mere 3 degrees. Consider the current state of our planet. It is warming. NASA data indicates temperatures could rise by 4 degrees before the century ends. If the climate reverts to the conditions of 60 million years ago, could the megafauna of that era re-emerge? Furthermore, how did Earth produce such gigantic beasts immediately after the extinction of the dinosaurs? The story begins in 2009. In Colombia, the Cerrejon mine stands as one of the 10 largest open-pit coal mines in the world. One day, a miner working at a depth of 60 meters unearthed a peculiar bone fossil. He casually tossed it to a visiting paleontologist nearby. That casual act led to a breakthrough. Upon receiving the specimen, the paleontologist froze. It was a vertebra, roughly the size of a grown man's fist. His initial hypothesis was that it belonged to a crocodile. After all, 60 million years ago, crocodiles were the undisputed apex predators of the swamps. However, there was an inconsistency. The morphology was incorrect. Crocodile vertebrae possess a specific arc and structure. The curvature of the specimen did not match. The scientists realized the anomaly. They immediately transported the fossil to the laboratory for rigorous comparative analysis. After countless measurements, they arrived at a stunning conclusion. This was not a crocodile. It was a snake, exceeding 15 meters in length. According to researchers at the University of Florida and their paleontological models, the dimensions of the vertebrae indicate a total body length between 12.8 and 15 meters. A total body length between 12.8 and 15 meters. Conservative estimates place its weight between 1 and 1.135 tons. Conservative estimates place its weight between 1 and 1.135 tons. To visualize these figures, consider this comparison. A standard city bus is approximately 12 meters long. This snake would extend 3 meters beyond that bus. Furthermore, it was not a slender creature. At its thickest point, the body diameter exceeded 1 meter. A human standing beside it would not even reach the midpoint of its height. The cranial data is even more intimidating. Its skull measured 40 centimeters in length, larger than a standard pillow. This implies that, when it unhinged its jaws, it could engulf an adult human head entirely with room to spare. The largest extant snake, the green anaconda, has a maximum recorded weight of around 227 kilograms. The Titanoboa was 5 times that mass. One would need to combine 5 giant anacondas to approximate its weight. Yet size was not its most lethal attribute. Its true power lay in its constriction force. According to biomechanical models, the Titanoboa exerted a pressure exceeding 400 pounds per square inch psi. To convert this into metric terms, that is approximately 28 kilograms of pressure per square centimeter. For context, a human subjected to just 100 psi would be unable to breathe. At 400 psi, ribs would shatter instantly, organs would be crushed, and the circulatory system would fail within 3 seconds. It did not kill slowly. It was an explosive strike. Once ensnared, incapacitation would occur within 0.3 seconds. Within 3 seconds, hypoxia would cause loss of consciousness. It would then spend hours, perhaps an entire day, consuming the prey. Escape would be biologically impossible. What sustained such a creature? The answer is in the fossil record. It preyed on crocodiles. Scientists have discovered fossils of several ancient crocodile species in the same stratum, such as the Cerrejon. These crocodiles were formidable predators in their own right. Growing up to 3 or 4 meters in length, they possessed an astonishing bite force. But on the Titanoboa's menu, they were merely appetizers. Based on the fossil record, a single adult Titanoboa could devour 15 to 20 medium-sized crocodiles in a month. Sight, see, the Titanoboa barely moved on land because its mass was simply too great. With a body 15 meters long and weighing over a ton, every inch of movement on solid ground was agonizing. Its internal organs would be crushed under its own weight. Breathing would become extremely difficult, and its digestive system would struggle to function. Therefore, it spent most of its time submerged in water. The water's buoyancy perfectly supported its massive bulk, allowing it to glide with effortless grace. Picture the scene: a murky tropical swamp. The surface littered with decaying leaves and animal carcasses. Visibility is near zero. Then, you notice something. A small patch of water ripples ever so slightly. It is the eyes and nostrils of a Titanoboa, just barely breaking the surface. It could lie in ambush, motionless, for days or even a week, resembling nothing more than a drifting log, virtually undetectable. What is it waiting for? It waits for prey to deliver itself. The moment a crocodile, turtle, or large fish enters, its striking range, roughly 1/3 of its body length, or about 5 meters, it launches an attack within 0.3 seconds. A speed so fast, reaction is impossible. 1 coil, 2 coils, 3. Winding and tightening. A terrifying pressure of 400 pounds per square inch is instantly applied. The prey skeleton snaps with a sickening crunch. The entire process takes less than 10 seconds. After consuming a 3-meter crocodile, it might go a month or even 2 without needing to feed again. This is the advantage of being an ectotherm, a slow metabolism and low energy consumption. A single meal sustains it for a long time. But here arises the question, if it was such a perfect apex predator, such a powerful prehistoric behemoth, why did it go extinct? Why is it no longer found on Earth today? The answer lies in a simple yet incredibly surprising factor: temperature. A mere shift in temperature was enough to wipe out the entire species. Titanoboa was a cold-blooded animal. Unlike mammals, it could not generate its own body heat, relying entirely on the ambient temperature to drive its metabolism. Earth, 60 million years ago, was significantly hotter than it is today. Climate models from NASA and the USGS have reconstructed the Colombian rainforest of that era. The average annual temperature ranged between 32 and 34 degrees Celsius. There was no winter, no cool season. The entire year was like a giant hothouse. Atmospheric carbon dioxide levels were more than 50% higher than modern levels. The greenhouse effect was incredibly intense. It was precisely this extreme high-temperature environment that allowed Titanoboa to attain such terrifying proportions. For cold-blooded creatures, the higher the temperature, the faster the metabolism, the higher the digestive efficiency, and the more rapid the growth. By analyzing the Titanoboa's body size, scientists have reverse-engineered the climate conditions of that time. This snake is, in essence, a living thermometer, a climate archive from 60 million years ago. A climate archive from 60 million years ago. Its existence proves that the tropics of the Paleocene epoch must have been at least 8 to 10 degrees Celsius warmer than today. Otherwise, the environment could not have supported the survival of such a massive ectotherm. In that era, it wasn't just the snakes that were giant. Everything was supersized. Giant turtles, 8 feet in length, 13-foot crocodiles, and 7-foot lungfish all were supersized additions. The entire ecosystem expanded wildly under the extreme heat, as if pumped full of steroids. But Earth could not maintain such high temperatures forever. Following the Paleocene epoch, the global climate began a slow cooling process. Over the course of several million years, the average temperature dropped by approximately 3 to 4 degrees Celsius. That may not sound like much, does it? It merely shifted from around 32 degrees down to 28, which is still a very warm climate. But for the Titanoboa, this was a catastrophic sentence. As soon as the temperature fell, its metabolism immediately slowed down. Digestion became sluggish, movement became lethargic, and hunting efficiency plummeted. It needed to consume immense amounts of food to maintain its massive body size, but it could no longer catch enough prey. So it began to slowly starve. This wasn't a quick starvation over a few days. It was a gradual decline over millions of years, where each generation became weaker and each generation grew smaller in size, a chronic demise leading to total extinction. Even more critical was the fact that its rivals were on the rise. After the extinction of the dinosaurs, mammals began an explosive period of evolution, growing larger and larger. They were endotherms, warm-blooded animals. Regardless of how the air temperature fluctuated, they could maintain a stable body temperature and vitality. While the Titanoboa became sluggish due to the cooling, mammals remained active and energetic. They usurped the Titanoboa's ecological niche, consumed its food sources, and squeezed it out of its habitat. The once mighty lord of the swamp was thus ruthlessly eliminated by the changing era. It wasn't due to natural predators, and it wasn't strictly due to competition. It was simply because the Earth's temperature dropped by 3 degrees. 3 degrees, such a simple number, ended the reign of the largest snake in Earth's history. Of course, snakes didn't instantly grow to 15 meters. Evolution requires time and millions of years of natural selection. But the crux of the matter is, when the Titanoboa was going extinct, it had no idea it was disappearing. It simply felt the weather get a little cooler, prey became a little scarcer, and its body felt a little heavier. Then, one day, the very last Titanoboa closed its eyes, and an era quietly came to an end. The next time you see news about global warming, think of this snake. 3 degrees is the distance between life and death. 3 degrees can cause a hegemon that ruled the swamps for millions of years to vanish completely. And right now, we are playing a dangerous gamble. The stake is the future of the entire ecosystem, the fate of all species, including us humans. The story of the Titanoboa teaches us a brutal truth. In the face of nature, there are no eternal rulers. No matter how powerful you are, no matter your position on the food chain. Once the environment changes, everything is reshuffled. Dinosaurs ruled the Earth for 160 million years, yet a single asteroid wiped them out entirely. The Titanoboa dominated the swamps for millions of years, yet a 3-degree temperature shift drove it to extinction. So, what about humanity? Can we, who call ourselves the masters of creation, really survive through drastic climate change? Will we endure? Or will it be that millions of years from now, when another intelligent species unearths our fossils, they will marvel at our past glory and then shake their heads, lamenting our stupidity?